A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
I was looking at the notes from President Zelensky's latest intelligence briefing this morning, and it is pretty sobering stuff. He was describing the emergence of what they are calling the Shahed 3 variant. It is not just a minor upgrade or a software patch. It looks like a fundamental shift in how these two countries are collaborating on the hardware level. We are seeing the fruits of a multi-year industrial marriage that has finally moved out of the honeymoon phase and into full-scale, high-output production.
Herman Poppleberry here, and man, this is a deep rabbit hole you have found for us today. Today's prompt from Daniel is about that exact Russia-Iran military-industrial nexus. Specifically, he wants us to dig into how this relationship has evolved from Russia just buying off-the-shelf kits back in 2022 to this fully integrated, high-volume manufacturing cycle they have built in the Alabuga Special Economic Zone. It is a massive facility in Tatarstan, and it has become the beating heart of this new drone doctrine.
It feels like we are past the point where we can call this a simple arms deal. When you look at the sheer scale of what is happening in Alabuga, it is clear that Russia has successfully indigenized a huge portion of the Iranian design. I'm curious, though, because the early narrative, especially in the Western media, was that these were just lawnmower engines strapped to a wing. They were treated as a bit of a joke, or at least a desperate stopgap. Is that still the case, or has the tech actually matured into something more formidable?
The lawnmower engine meme was always a bit of a reductionist take, but the jump from the original Shahed 136 to what we are seeing now in early 2026 is massive. The core shift is moving away from being a customer to being a co-developer. In the beginning, Iran would ship the crates, Russian technicians would bolt them together, and they would launch. Now, the Alabuga facility is iterating on the design in real time based on battlefield data that is coming straight from the front lines in Ukraine. We are talking about a closed-loop engineering cycle where a failure on Tuesday results in a design tweak on Friday and a new production batch by the following month.
So it is a feedback loop. Russia provides the testing ground and the industrial scale, and Iran provides the foundational blueprints and the asymmetric warfare philosophy. But what does that mean for the actual guts of the drone? If I am a radar operator on the ground in Kiev or Kharkiv, am I seeing the same signature I saw 2 years ago?
Not even close. One of the biggest technical leaps in the Shahed 3 is the reduction in the radar cross-section. They are using new composite materials and radar-absorbent coatings that were not present on the original Iranian models. They have moved away from simple fiberglass to carbon fiber weaves that are much harder for older radar systems to pick up. But the real magic, if you want to call it that, is in the navigation. The early models relied almost entirely on commercial-grade GPS. If you jammed the signal, the drone would just drift off course or fly into the ground. It was a very brittle system.
And I assume they have fixed that vulnerability, because we have seen how aggressive the electronic warfare environment has become.
They have gone for a belt and suspenders approach. They have integrated hardened anti-jamming inertial navigation systems, or INS, which allows the drone to maintain its flight path even if the satellite link is completely severed. They are using something called the Kometa M antenna, which is a Russian-designed digital antenna array that is incredibly resistant to jamming. Plus, they have integrated Russian GLONASS support alongside the standard GPS. Having access to multiple satellite constellations makes it much harder for electronic warfare units to create a total blackout. If one signal is compromised, the drone just switches to the next available one without skipping a beat.
It is interesting you mentioned the electronic warfare aspect. I remember we touched on the concept of physical DDoS attacks back in episode 1198, when we talked about Swarm as a service. It feels like this is the industrial realization of that theory. If you can produce these things at the scale they are doing in Alabuga, you do not need them to be perfect. You just need them to be good enough to force the defender to use an expensive interceptor.
That is the core of the Russian strategy. The Alabuga facility has reportedly increased its production capacity by an estimated 40% since the third quarter of 2025. We are talking about thousands of units a month. When you have that kind of volume, you can afford to lose 90% of your swarm if the remaining 10% hits a high-value target like a power substation or a command center. It is a mathematical certainty. If I send 50 drones at a target and it costs you $2 million per missile to shoot them down, I am winning the economic war even if none of my drones actually hit the target.
But how are they getting the components? We have been told for years that sanctions have cut off the flow of high-end microchips. If these drones are getting more sophisticated, where is the silicon coming from? Are they making their own chips now?
This is where it gets frustrating for the policy wonks. Most of the flight controllers and signal processors in a Shahed are not military-grade chips. They are dual-use components that you can find in a high-end consumer drone or even a smart washing machine. We are talking about microcontrollers from companies like ST Microelectronics or Texas Instruments. They are being routed through third-party distributors in places like Central Asia, the Caucasus, or East Asia, places that do not observe Western sanctions. The blackout incident in Kharkiv back in January was a perfect case study for this. When the wreckage was analyzed, they found flight path algorithms that were significantly more complex than anything we had seen before, running on microcontrollers that were technically restricted but clearly still available in bulk.
So the sanctions are essentially a speed bump rather than a wall. If they can get the chips and they have the composite manufacturing in Alabuga, they are basically running a continuous improvement cycle. It reminds me of the cluster missile doctrine we discussed in episode 1093. It is not about one big expensive silver bullet. It is about a shimmering curtain of steel and silicon that overwhelms the defense through sheer numbers and iterative refinement.
The comparison to the cluster missile shift is very apt. In that episode, we talked about how Iran moved from single warhead precision to high volume saturation. Now, they have exported that philosophy to Russia, and Russia has given it the industrial muscle it never had in Iran. The Shahed 3 even incorporates a new dual-link satellite communication module. This is huge because it reduces the reliance on local ground stations. They can retarget the drones in mid-flight from thousands of miles away using a secure satellite uplink. This is a level of command and control that was previously reserved for high-end cruise missiles costing millions of dollars.
That sounds like a nightmare for air defense. If you can change the target while the drone is already in the air, you can bypass the areas where you know the mobile fire teams are waiting. You are essentially playing a real-time strategy game against a defender who is tied to static positions.
It is exactly a real-time strategy game, and the data from those flights goes right back to the engineers in Tatarstan. If a drone gets shot down by a specific type of German-made anti-aircraft gun, the engineers look at the telemetry and ask, how can we change the flight profile to avoid that specific radar signature next time? It is an evolutionary process happening at a speed that traditional Western procurement cycles just cannot match. While a Western defense contractor is still filling out the paperwork for a design change, the Alabuga plant has already pushed out 500 units with the fix.
I want to pivot slightly to the strategic implications here. We are focused on the Ukraine theater because that is where the hardware is being used. But what happens when this Alabuga model gets exported back to the Middle East? If Iran starts using these Russian-refined manufacturing techniques to supply their proxies, the Ring of Fire, we talked about in episode 945, becomes a lot more dangerous.
That is the second-order effect that keeps Israeli and Saudi defense planners up at night. If Hezbollah or the Houthis get access to Shahed, 3-level tech with the manufacturing efficiency of the Alabuga plant, the Iron Dome and other interceptor systems face a serious math problem. We are talking about a $20,000 drone versus a $2 million interceptor missile. You do not have to be a math genius to see that the defender loses that war of attrition every single time. The DDoS effect we mentioned earlier isn't just a tactical problem, it's a strategic bankruptcy for the defender.
It is a strategic paradox. By helping Russia, Iran is essentially getting a free masterclass in high-volume, high-tech manufacturing. They are learning how to bypass Western electronic warfare, how to harden their navigation systems, and how to scale production in the face of global sanctions. It is a massive transfer of operational knowledge.
And it is not just one way. Russia is getting a low-cost way to keep the pressure on, while Iran is getting a seat at the table with a major global power. It is a partnership of necessity that has turned into a partnership of genuine innovation. One of the things that blew my mind in the recent reports was the reduction in the radar cross-section. They are not just using coatings, they are actually changing the geometry of the airframe to make it more stealthy. They have smoothed out the wing body joints and hidden the engine intake more effectively. It is not F-35 level stealth, obviously, but it is enough to reduce the detection range by maybe 30 or 40%. In a swarm, that is the difference between being intercepted and reaching the target.
So, what is the counter? If the kinetic approach, shooting them down with missiles, is too expensive and ultimately unsustainable, where does the defense go from here? We can't just keep throwing $2 million interceptors at $20,000 drones forever.
The answer has to be non-kinetic. We are talking about directed energy weapons, like high-powered lasers or microwave emitters, and much more aggressive electronic warfare. The problem is that as the drones get more autonomous, EW becomes less effective. If the drone doesn't need to talk to anyone and can navigate purely by looking at the terrain using computer vision, you can't jam it. You have to physically destroy it. This is why systems like the British Dragonfire laser or the Israeli Iron Beam are becoming so critical.
Which brings us back to the cost per intercept problem. If you're using a laser, your cost per shot is basically just the cost of the electricity, which is great. But the range is limited, and weather can be a factor. If it is foggy or raining, the laser's effectiveness drops off a cliff. It feels like we are in this weird arms race where the offense has a massive lead because they have embraced cheap and fast, while the defense is still stuck in expensive and perfect.
I think you hit the nail on the head. The Alabuga facility is the physical manifestation of that cheap and fast philosophy. They are willing to accept a high failure rate because the cost of failure is so low. Meanwhile, if a Western air defense system fails once, it is a national scandal and a congressional inquiry. That asymmetry is what Russia and Iran are exploiting. They are playing a different game with different rules.
Let's talk about the specific incident I mentioned earlier, the Kharkiv blackout in January. What was it about that attack that signaled a shift in the flight path algorithms? Why did that catch the attention of the analysts?
In previous attacks, the drones would mostly fly in relatively straight lines or follow predictable waypoints. They were easy to track once you spotted them. In the Kharkiv incident, the drones were performing complex maneuvers, changing altitude rapidly, looping back on themselves, and coordinating their arrival from multiple different vectors simultaneously. It looked like they were purposely trying to drain the local air defense by forcing them to engage decoys while the live round snuck in from a different angle. This kind of coordinated, multi-vector attack requires a level of processing power and software sophistication that we just hadn't seen in the earlier Shahed models.
That sounds like they're moving toward true swarm intelligence. Not just a bunch of drones flying in the same direction, but a group of drones that are aware of each other and can coordinate their behavior in real time.
We are not quite at full hive mind autonomy yet, but we are definitely seeing the precursors. The Shahed 3 variants are reportedly being tested with basic optical sensors that can recognize certain types of terrain or even specific building shapes. This is template matching navigation. It is old tech in the world of high-end cruise missiles, but bringing it down to the level of a disposable drone is a massive leap. If the drone can see where it is by comparing the ground below to a preloaded map, it does not need GPS at all. It becomes immune to traditional jamming.
And if it does not need GPS, the entire Western electronic warfare playbook for the last 20 years basically goes out the window. That is a terrifying prospect for static infrastructure like power plants or water treatment facilities.
It really is. And the most concerning part is how this tech is being battle-hardened. Every time a Shahed gets shot down or jammed, the Russians and Iranians get a data point. They are essentially using the entire Ukrainian airspace as a giant R&D lab. They are iterating faster than any peacetime military could ever hope to. They are learning what works against Western systems in real time, and they are feeding that knowledge back into the Alabuga production lines.
It also makes you wonder about the role of other actors. We know China has been watching this very closely. While they are not officially part of this specific production nexus, the dual-use components we talked about often originate there.
The China connection is the elephant in the room. While they are careful not to provide direct lethal aid in a way that would trigger massive sanctions, they are the primary source for the small engines, the carbon fiber, and the microelectronics. In many ways, the Russia-Iran-China triad is creating a parallel military-industrial complex that is entirely decoupled from Western supply chains. This is what we touched on in episode 1011 regarding Israel's security paradox. How do you navigate a world where your traditional allies are being outproduced by a bloc that does not play by the same rules?
It feels like the era of Western technological superiority is being challenged not by better tech, but by good enough, tech produced at an impossible scale. It is the T-34 tank philosophy applied to 21st century autonomous systems. You don't need the best drone, you just need more drones than the enemy has bullets.
That is a perfect analogy. The T-34 was not the best tank of World War II. It was cramped, the optics were poor, and it broke down constantly, but there were so many of them that it didn't matter. The Shahed is the T-34 of the drone age. And with the Alabuga plant reaching full stride in 2026, the volume is only going to increase. We are looking at a future where the sky is constantly filled with these smart junk systems.
So, for our listeners who are following this, what are the practical takeaways? If you are a defense analyst or just someone interested in the weird side of tech, what should you be looking for as the next indicator of where this is going?
First, keep an eye on the dual-use component trade flows. If you see a sudden spike in a specific type of high-end optical sensor or a particular class of microcontrollers being shipped to Central Asia or the Caucasus, that is often a leading indicator of a new production run or a design shift in Alabuga. There are some incredible OSINT, that is, open source intelligence communities on Telegram and Twitter that track these things in real time. They look at shipping manifests, satellite imagery of the Alabuga plant, and even the serial numbers on recovered drone wreckage.
It is also worth looking at the directed energy space. If we want to see how the West plans to counter this, that is where the real innovation has to happen. We're starting to see the first deployments of truck-mounted laser systems that can take out a drone for the cost of a gallon of diesel. The race is on to see if those can be fielded fast enough to protect critical infrastructure before the math problem of the interceptors becomes insurmountable.
The other thing to watch is the integration of AI for target acquisition. We are hearing rumors that the next iteration of the Shahed might have enough onboard processing to identify specific military vehicles, like a Patriot missile launcher or a HIMARS unit, without any human intervention. If they can move from hitting a coordinate to hunting a target, the game changes entirely. It turns a suicide drone into an autonomous hunter-killer.
That is a huge leap. If the drone is autonomously hunting, you are no longer just defending a city. You are defending every single mobile asset you have, all the time. It forces you to stay hidden, which limits your own operational effectiveness.
And that is why the Russia-Iran nexus is so significant. It is not just about the drones themselves, it is about the fusion of Russian aerospace engineering with Iranian asymmetric warfare philosophy. They are teaching each other how to fight a high-tech war on a budget. They are proving that you can challenge a superpower without having to match their defense budget dollar for dollar.
It is a sobering look at the future of conflict. It feels like we are seeing the end of the exquisite weapon era, where we spent billions on a handful of perfect platforms. The future belongs to whoever can build the most smart junk and throw it at the enemy until they run out of expensive bullets. Can the West disrupt the supply chain faster than the Russia-Iran partnership can iterate the design? That is the multi-billion-dollar question.
I think that is a very fair assessment. It is a paradigm shift that a lot of people in Washington and Brussels are still struggling to wrap their heads around. But the wreckage in Ukraine and the smoke over the Alabuga facility are proof that the shift is already here. We are living in the age of the industrial drone.
Well, this has been a fascinating, if slightly terrifying, deep dive. I think it is clear that the Shahed 3 is just the beginning of a much larger trend toward autonomous, high-volume warfare.
It definitely is. And as long as Daniel keeps sending us these prompts, we will keep digging into the technical weeds to see where it leads next. There is always something new popping up in the OSINT reports.
Before we wrap up, I want to say thanks as always to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes and making sure we don't drift off course.
And a big thanks to Modal for providing the GPU credits that power this show and allow us to process all the data we dig into every week.
If you are finding these deep dives useful, do us a favor and leave a review on your podcast app. It really does help other people find the show and keeps us motivated to keep exploring these weird prompts.
You can also find us at myweirdprompts.com for the full archive and all the ways to subscribe.
We will be back next time with another deep dive into the strange and the technical. This has been My Weird Prompts.
See you then.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts.